Hi, I'm Gurleen Kaur and I am the student of Loyalist College of Computer System Technician, and now I would like to represent the PowerPoint presentation of communication subject, which is based on the basic network design and development. And the name of my group is Data Pirates, and my team members are Kirandeep Kaur, Chobanpreet Singh, Taranveer Singh, Sagar Singh Chima, and Vishal Jain. Now I would like to represent my first slide to you. So this is my first slide in which I would like to explain the scenario of network design and development. In this design, there is the office, which is divided into 4 floors, each with its own set of requirements. For the company's research wing, the topmost floor will have to host 150 machines apiece. In addition, it must be capable of supporting wireless communication for 60 mobile nodes at any same moment. As a basic work environment, the third level will need to provide wired communication for 70 machines. On the third level, the CEO and CTO, as you know, CTO is Chief Technical Officer. These offices will be located and both will require secure wireless access. As a result, the third story requires a secure Wi-Fi connection. The server room on the second floor will house an FTP mail and web server, as well as a corporate firewall system that will provide the edge for the internet and branch offices. Area first on the first level will contain all customer handling nodes, which will total 30 machines. Okay, so I would like to move to the next slide now, in which I would show you a diagram. Okay, so this is the diagram of main site and its branches, which are interconnected with the network design. So you can see here there is the 4 floor. In the first floor, you can see there is the telecommunication closet, which are connected with the 24 port switch. With the help of the patch panels, it is connected with the 4 workstations, and these patch panels are having wall sockets on each panel. So you can see here this first floor is interconnected with the second floor, and in the second floor there are the 2 core switches. This is the core switch first, this is the core switch 2, and these 2 switches are also interconnected with each other. Core switch first is connected with this switch, and core switch 2 is also connected with the switch. With the help of these cables, the server room are consist switch, FTP server, DNS server, mail server, radio server, and DHCP server. These all the servers are connected with the main switch here. Okay, so the core switch 2 and the core switch 1 are interconnected with each other, and both these switches are having 2 routers. There are the core router first, core router 2, which are connected with the firewall. Firewall are further connected with the gateway router and the internet connectivity with the web server DM set. Okay, so this second floor are connected with the third floor. You can see here this floor is connected with the third floor. In the third floor there are the 2 port switches. First is 24 port switch, second is the 48 port switch. These switches are connected with the 3 workstations, and 3 workstations are connected with the telecommunication closet with the help of the patch panels, and there are also the wall sockets on the 3 workstations. This telecommunication closet are also connected with the CEO and CT room. As I discussed in the previous slide, CEO office is the secure wireless access which is provided by creating a separate VLAN for the wireless communication and using a VPA2 enterprise protocol. A VLAN helps to logically group the workstations that are connected to the access point in the third floor. By this, unnecessary broadcast traffic will not reach the third floor at the wireless network. WPA2 Enterprise Protocol provides the additional security needed for this wireless network. It helps to centralize the control over this wireless network. Users are pre-assigned with login credentials and they must provide it when they connect to this wireless network. User authentication and centralized management is done through the radius server, which is in the second floor. You can see here in the second floor there are the radius converters. Okay, so you can see here the third floor is connected with the fourth floor are interconnected with the second floor, and in the fourth floor there are also the telecommunication closet, which consists 3 port switches. As you see here, in the first floor there are only the one switch, and then the second floor there are the 2 switches, and then indirectly the fourth floor there are the 4 switches, and the 4 switches are the 3 switches: 24 port switch, 48 port switch, and 48 port switch. Okay, so these switches are connected with the 5 pieces: PC number 1, PC number 2, PC number 3, PC number 4, and PC number 5, with the help of the patch panels, and there are also the wall sockets on each PC. And this telecommunication closet are connected with the AP at the upper side and lower side, and internet connectivity is available in the fourth floor also. It will be always efficient to follow the structured cabling approach in designing a network. Structured cabling is made up of number of standardized elements called subsystems. The subsystems are entrust facility where ISP network ends and connects to customer devices. Equipment room where several equipment and other parts of network that serve the clients inside the building. Backbone cabling, as you see here, it is the backbone cabling which interconnects different floors together with the high speed cables. Horizontal cabling which interconnects the components inside the same floor. This is the horizontal cabling which connects the components in similar floor. Okay, so horizontal cabling which interconnects the components inside the same floor. Work area where the end user equipment connect together with the horizontal cabling, and telecommunication enclosure which interconnects horizontal cabling and backbone cabling together. So in this network design, also structured cabling approach is followed. Work area subsystem is comprised of several end user workstations which are connected to the wall socket through RJ45 cables. Work area also includes wireless station communicating with the nearest access point. Horizontal cabling in this network is made up of 100 megabytes, and Ethernet cables which joins the wall sockets, as you can see here, which joins the wall sockets with the help of the horizontal cabling. It connects the wall sockets and the backplane of patch panels. Telecommunication enclosure subsystem, this is the telecommunication enclosure subsystem in this network design, consists of switch chassis and patch panels. You can see here there is the switch chassis and patch panels. Patch panels wires are used to connect front end of patch panel and individual switch in the switch chassis. The reasons to use patch panel in this network design are identification. Ports in patch panel can be labeled to uniquely identify which cable come from which location, is getting terminated on which port of patch panel. So it is easy in disconnecting and connecting and testing a cable. Small changes in network cabling wouldn't affect the switches and switch chassis, so changes can be made quickly and easily. All the cables can be terminated on the patch panel, and they could be selectively connected to the switch chassis, connected with the switch chassis. So another important part of this subsystem is switch chassis, since around 100 wired end user connections are needed on 4th floor. Three switches were used in this design. Switches are stacked on the top of each other. Each switch inside the stack are interconnected between them using first gigabit per Ethernet ports. So, the main advantages of using stackable switch model in this network designs are network maintenance becomes easy. Scalability, the network can grow up additional switches over the time when needed, thus reducing the management complexity. Even one unit fails, data will continue to flow through other units, thus provides the resilient connections. In 3rd floor, there are only the 2 switches, and the other main subsystem of this network design is backbone cabling. Backbone cabling is made up of fiber optics and interconnects the backplane of switch chassis and the core switch, which reside in the 2nd floor. The reasons to use 2 backbone link is to provide redundant connection during failure. And the other main subsystem is the equipment room. The 2nd floor design is to be considered as the equipment room. The 2nd floor consists of 2 core switches, 2 core routers, firewall, gateway router, server room, and a demilitarized zone which hosts web server for internal access as well as for outside access. The reason to use 2 core switches is to provide the redundancy and to avoid the single point of failure. Fiber optic cables coming out from the switch chassis in each floor, and the switch inside the server room is terminating in each of these core switches separately. These core switches are also interconnected between them. Okay, so in the 2nd server room, there are the 2nd floor, which consists the FTP server, mail server, AD radio server. As you can see here, there are the FTP server, DNS server, mail server, radio server, and DHCP servers. Okay, these servers are used for the authenticating users for different services that is provided across the network. DNS server for DNS lookup services, and DHCP server which dynamically assign IP addresses to hosts in different VLANs and the network. All the servers inside the server room and the web server in DMZ is configured with the static IP addresses. The reason to assign them with static IP address is to reduce the downtime in IP renewal process, convenient remote access, and stability for the applications running inside these servers. All these servers are connected to the central switch through 100 megabytes speed cables, and in turn this central switch is connected to the 2 core switches independently through 1 gigabyte speed cables. And the other subsystems is the entrance facility is shown by the connection between the internet cloud. As you can see here, there is the internet cloud. Okay, so this internet cloud and the firewall which is situated in the 2nd floor of the building. This is the 2nd floor of the building. So now I would like to move to the next slide. This is the next slide in which there are the main site to branch first and branch 2, you can see here there is the main site which is connected with the firewall gateway router, and this gateway router are connected with the branch first and branch 2 with help of the leased line. And in this there is the frame relay cloud which are connected with the branch first and branch 2 with the help of the access link. There are also the VPN over the internet which are connected with the mobile worker and firewall. Okay, so this is the main site to branch first and branch 2 fiber optic point to a point leased line connection, frame relay connection branch first and branch 2. There is the using VPN via the internet. Mobile workers may connect to the main site network. As you can see here, there is the main site network with the help of the VPN. Mobile worker are connected with the main site. Okay, now I would like to move to the next slide in which I will show you some assumptions and development of network design. So this is the next slide in which there are some assumptions and development of network design. There will be constant data flow between the main site and the branch offices. Two branch offices are adjacent to the main headquarters. As a result, having a leased line connection from the main site to branch locations is less expensive. Because there is a little data flow between the two branch offices, they have a permanent virtual circuit link through frame relay. A PVC is established between two branch offices with a dedicated committed information rate. Because of the large data transmission between sites, the small distance, and the fact that only two interfaces will be utilized in the gateway router to link the main site and its branches, leased lines are recommended to connect the main site and its branches. So, I would like to move to the next slide. This is the slide in which there are some assumptions which are based on the configuration. As you can see here, there is the backbone cabling, horizontal cabling, work area and telecommunication enclosure subsystem. These all the configurations are the assumptions which I discussed in the previous slide, in which I will show you I was showing you a diagram of the 4 floors. So this is the 4 main assumptions which are based on the configuration, which I already discussed to you. So guys, I will move to the next slide. This is the slide in which there are some role of equipment room and server room. I also discussed to you in the previous slides like equipment room and server room, but now I will explain you. The web server is accessible to both the public and network considers. CEO and CTO room, which I discussed 2 times previously. CEO and CTO room has less than 15 individuals working in it. 2 branch offices are near to the main headquarters. As a result, having a leased line connection from the main site to branch locations is less expensive. At all times, a lot of data is being sent between the main site and the branch offices. Because there is a little data movement between the 2 branch offices, they have a permanent virtual circuit, which we can say PVC link through a frame relay. Okay, only a few computers were represented in the network diagram due to the lack of space. So now I will move to the next slide. This is the next slide in which there are the network protocol used in network. There are the 6 protocols. First is DHCP. DHCP is the dynamic host configuration protocol. DHCP service is installed in the DHCP server which resides in server room. IP address pool for different VLAN will be created in DHCP server. So DHCP server dynamically assign the IP address to the host in the network. Static IP address that will be used within the VLAN can be removed from the IP address pool in DHCP server. The next is STP server. STP servers means standardized test procedure. In this, the redundant link connection is provided between the switches in each floor to the second core switch is located in the second floor. Also, redundant link is added between two core routers. The purpose of having an extra link is that if one link goes down, still the network components can communicate with each other using the redundant link. Next is NAT, Network Address Translation. Class B private range IP address is used with inside this network, but the host cannot communicate with this private IP address over internet because private IP addresses are not routable in internet. The next is HSRP, which means Hot Standby Router Protocol. This is configured by combining the two core routers in this network. Therefore, the two core routers will act as a single virtual router for the internal host. One core router will assume the responsibility as active router, while other will take responsibility as the standby router. So there is the next protocol, which is VLAN, Virtual Local Area Network. There are the 7 different VLAN created across this network. Each VLAN for different floor and separate VLAN for wireless network in 4th and 3rd floor. This is to remove the uncontrolled broadcast traffic reaching another network. VLAN also provides a layer of network security and cost reduction option by logically separating hosts which is connected to the same switch. Now, I would like to move to the next slide. There is the summary. The office has 4 floors, each with different requirements, including machines and servers. Configuration of the network is mostly depending on the structured cabling. The structured cabling includes various subsystems, each having different functions. The area subsystems are made up of several end users. The telecommunication enclosure subsystem is made up of switches and patch panels. Switching may be configured to work as a stackable switches. Backbone cabling is another important component of network design. Each floor has 2 backbone cables to connect with each other. The equipment room is another major component. These are considered on the 2nd floor. There is a firewall in the network that is used to filter traffic towards the inside network. The secure wireless access for the 3rd floor CTU is provided by creating a separate VLAN for the wireless communication and using WPA2 enterprise protocol. DHCP service is installed in the DHCP server, which is in the server room. STP provides the connection between the switches in each floor to the 2 core switches located in 2nd floor. NAT provides the Class B private range IP address. By using NAT public IPv4 address, the host can communicate without any disruption even one core router falls. HSRP is configured by combining the 2 core router in the network. VLAN provides the 7 different VLANs for different floors. Access control lists are used in firewall to filter traffic from outside, reaching the internal network. Virtual private network is used for the communication between the main site and the mobile worker. So in the last slide, there are some references. Thank you.